a good terrain masking back here. Yeah, we're safe now, except for the mirror.
Crew. Moments before they were faced with the most critical decision, when to eject from their out-of-control aircraft. A delay in making this decision, for whatever reason, may well have cost them the opportunity to make a successful escape and added 2 more statistics to the ever-growing number of Air Force aircraft fatalities. Fatalities that shouldn't, but continue to happen. Since the first aircraft ejection in August 1949, there have been 4,600 air crewmen who have punched out. Of these, if we concentrate on the ejection survival rate for the last 5 years, we see a less optimistic picture. Here, the survival rate average drops to 75%. Accident analysis reveals that the majority of these fatalities were not due to mechanical problems, failure of the egress system, or improper parachute landing technique. Rather, they were the direct result of delayed ejection. The Air Force Inspection and Safety Center is well aware of this problem. Single motion initiation, rocket catapults, automatic opening lap belts, ballistic powered inertia reels, seat man separators, seat stabilization devices, force deployed parachutes, and automatically deployed survival kits are just some of the improvements which were designed to facilitate crew members' escape. Some of our newer aircraft, such as the A-10, the F-15, and the F-16, are equipped with the new ACES 2 ejection seats that even surpass our other highly refined escape systems.
There is some evidence that tends to suggest that many air crew members interpret escape system improvements as being additional time to overcome an emergency. This, of course, is not why escape systems are improved. They are improved to give crew members a better chance to escape.
Yet, in spite of the many safety improvements, escape technology is still having a hard time keeping pace with the demands placed upon it by improved aircraft performance, more complex missions, and more low-level flying now required in the current training environment. There must be time for the ejection sequence to fully operate prior to ground impact.
Therefore, delaying the decision to leave the out-of-control aircraft is and has been the single most critical factor in determining the success or failure of in-flight escape.
This is borne out by the high fatality rate in escape attempts outside the performance envelope of the system, at low altitudes, particularly below 500 feet.
No matter how good the escape system, you've got to give it time to work. As flight surgeon at the Safety Center, I've reviewed many accident reports involving the delayed ejection, and they always illustrate at least 2 points. One, these seats require a finite amount of time to work. For example, depending upon the airspeed, the rear seat out of the F4 requires 4 or 5 seconds from initiation to full parachute, and the front seat takes a second longer. And second, these systems were not designed to overcome the horrendous sink rates generated by aircraft out of control, which may exceed 600 feet per second. There's a good reason for those mandatory bailout altitudes. You just don't have much time. Not long ago, an F-4 crew was defending during a similar combat tactics engagement, and while pressing to defeat his attacker, the young pilot departed his aircraft at roughly 8,000 to 9,000 feet AGL above an overcast. Now, he had a reputation as being an aggressive, up-and-coming good stick, and he tried hard to salvage his mistake. but apparently he got a secondary stall to avoid going in the overcast, and in they went. While passing through the overcast, perhaps they became disoriented. We'll never know for sure, but one thing for certain is that both he and his Wizzo lost awareness for how fast that aircraft was really coming down. We have indications that that aircraft dropped the 8,000 or 9,000 feet in less than 16 seconds and possibly as little as 11 seconds for an average sink rate of between 500 and 700 feet per second. When it passed through 4,000 feet AGL, still unrecovered, it was going to crash and was fuel to stay with it. But when the aircraft broke to the bottom of that 1,500-foot overcast, with them still aboard, they were both dead men. The Wizzo did initiate a dual-sequenced ejection at something around 1,000 AGL, but barely achieved man-seat separation when he hit the ground. Amazingly, though the impact broke his thigh, that's not what killed him. He burned to death in a fireball.
Making the ejection decision in a wartime environment does not seem to be a problem. We know from our experience in Southeast Asia that there was little reluctance for crew members to go out of a battle-damaged aircraft. Their decisions were made quickly, almost automatically, without hesitation. As a result, there was a 95% survival rate. Yet in peacetime, the decision to eject from a disabled aircraft is not always an easy one to make. In-depth analysis of aircraft accidents reveals that a number of psychological factors may be deeply involved in the decision. One expert with insight into this very complex problem is Mr. Rudy Delgado, Egress System Safety Manager at the Air Force Inspection and Safety Center.
These are some of the other recorded reasons for delaying the ejection decision. Besides this, we think there's other things such as stigma, ego involvement, peer pressure, and command emphasis that tend to argue against a timely escape decision.
However, in my opinion, the single most important element in delayed ejection is lack of situation awareness. That is, the pilot becoming so engrossed in trying to overcome his problem that he loses awareness of the overall situation, such as altitude above the ground, the recovery envelope of the aircraft, or the safe escape envelope. This usually results in a late ejection attempt or no ejection attempt at all.
Situation awareness played an important role in a number of recent successful ejections. One, over the Nevada desert in late 1980, started out as a routine F-4G training exercise.
I'm Lieutenant Colonel Roger Ayers, stationed at George Air Force Base. Fly the F-4G Weasel. On 17th of December, we were up at Tonopah Electronic Warfare Range as I completed a strike shot on one of the emitters up there. Got a blink of master caution light. Started to climb out, and the entire caution panel had failed. As I checked the utility hydraulic pressure, it was down to 0. All other engine instruments read normally. Climbed up, leveled off about 13,000 feet and 350 knots. By this time had lost PC-1, PC-2, and utility. The aircraft started an uncommanded roll to the left. This time made a radio call that we were ejecting, and followed that by ordering the Evo to eject at that time. Watched him go through the mirror, and as soon as he cleared the aircraft, about 45 degrees of bank, I initiated ejection. Took until we were approximately about 130 degrees of bank, maybe 40 degrees nose low by the time my ejection seat fired. While the entire process took about 45 seconds from the first blink of a master caution light to ejection, the decision to eject probably was made back in pilot training. The aircraft was uncontrollable. I had no flight controls and no hope for recovery of the aircraft. If I had it to do over again, while I assumed a good position overall for ejection, I did not let go of the stick and did not pull the handle with both hands, and subsequently my right shoulder was broken during the ejection process.
While While the T-38 flight crew was practicing landing procedures at a Midwestern base, the pilot and her instructor experienced a right engine failure.
I'm Lieutenant Julie Thee. As a student pilot, I was recently involved in an emergency in a T-38 aircraft at my home base. We came back from a routine sortie to do a heavyweight no-flap touch and go, and as we were climbing out, we got a fire in the right engine. We shut the engine down, but the fire burned through the control cables that led to the stabilator, and we had no pitch control. About that time, my instructor said it was time to get out of the aircraft. I said, okay, looked down and pulled my hand grips up and waited to hear him go behind me. Heard the boom, I squeezed my triggers, and that was the end of it. It was not nearly as scary as I'd always thought it would be. I'd been really bad in aerospace physiology training. I just hated parachute landing falls, and I was terrified of ever having to eject. I thought I'd never have to do it. But when it came time to do it, my instructor pulled me through. If I'd been solo, I think I would have thought about it a lot longer. But my instructor was so calm about it that it didn't leave me any second thoughts. I just squeezed the triggers and went. And it didn't hurt. Everything worked just like it was supposed to. I know if I was ever in a situation like that again, I wouldn't hesitate for a second to pull the triggers because it works like it's supposed to and it doesn't hurt.
Over the California desert, an A-10 was test firing ammunition with a new flash suppressor. Lieutenant Colonel Rusty Gideon was piloting the aircraft and can relate what happened.
About 3 years ago, I was involved in a flight test mission out of Edwards Air Force Base in an A-10, during which some problems developed, which caused me to have to bail out. The problem was a double-engine compressor stall, which led to a double-engine overtemperature, and then I shut both engines down, attempted to cool them down so that I could then restart them. However, ran out of altitude before having completed that full sequence, so I had to bail out. I've always thought that it's sometimes difficult, sometimes easy to make an ejection decision. The easy ones are when your wing gets shot off, or your engine blows up, or your flight controls lock up. That's pretty self-evident that it's time to leave the aircraft. There's other times when the pilot hopes he can salvage the situation, or he hopes things are going to get a little bit better. But by waiting that extra moment, it's certainly possible that you're going to put yourself out of the ejection envelope. In my case, there was some question in my mind as I descended through what appeared to me to be 2,000 feet, because I had actually seen one of the engines light off and begin its start cycle. However, I've never regretted the decision to bail out when I did, because I'm still not sure that it would have lit off and that it would have provided the amount of thrust I would have needed to recover the airplane. As far as the ride in the parachute, it was a little bit violent at first. It takes about 2 seconds from the time you pull the handle until you're in the chute. Then it was very quiet, and once my senses caught up with what was happening to me, it felt very comfortable. I'd been there before numerous times during the training, and the rest of the ride down was very comfortable.
While conducting high angle of attack tests on an F-111, another pilot was faced with an ejection decision.
I'm Colonel Pete Winters. We were conducting high angle of attack testing on the F-111. On this particular day, we were conducting accelerated stalls at 35,000 feet to check the departure characteristics of the airplane. We had already conducted one test in which the airplane did depart as predicted, and a rolling departure, and then recovered rather rapidly. We decided to go to our second point. The second point was an accelerated stall, 2Gs. The airplane departed as predicted, but then went immediately into a spin. I applied the recovery controls, and the airplane started to recover. We thought we were going to make it, but we were coming down very rapidly and passed through our spin chute altitude of 22,000 feet. I deployed the spin chute as briefed, and the spin chute came off in the maneuver. Now things weren't going as predicted. Both engines were stagnated. As we passed through our ejection altitude, and my chase pilot yelled for me to eject, which I did after very little thought. I don't believe that up to that point I'd even thought about ejecting. Because the airplane was highly instrumented, we went back after the accident to determine how much time we had. We calculated 3 seconds. If we'd waited another 3 seconds, the chute would not have opened prior to hitting the ground. I don't know that I would have made that ejection decision in those 3 seconds if my chase pilot had not assisted me and yelled for me to eject. I was highly trained and prepared for my mission. I was prepared for the departure. I was not prepared for the violent recovery maneuver and the spin chute coming off. I don't know that if I departed in the operational world, if I could have made that decision to eject. It's important to know when it is that you want to eject and then abide by that decision while you're in the air.
Even the crews of our newest aircraft models, the F-15 and F-16, have experienced unexpected ejection situations. The idea of ejecting never occurred to one F-16 pilot until he saw how close he was to the ground.
I'm Major Paul Rossetti. We were flying at low altitude on an F-16 operational test mission when I looked over my shoulder and saw an aggressor aircraft attacking my element. We made a defensive turn. After that, I made a wing rock. Shortly following the wing rock, my airplane pitched up violently and went into a falling leaf maneuver. I was surprised. I immediately focused all my attention on trying to fly the airplane back under control. After 3 or 4 oscillations, the nose pitched down, then it pitched back up again. At that point, I checked my altimeter and it was reading close to target elevation. I then looked out the window, got a close-up on a cactus, and decided it was time to eject. The ejection occurred about 700 feet AGL, about 5 seconds after going out of control. The aircraft was in a very high sink rate at that time. It impacted the ground about 4 seconds after I ejected, and the 4,500 pounds of fuel on board made it a fairly sizable fireball. I was forced to make a 4-line jettison and steer my chute to miss the fireball. If I had waited another 2 or 3 seconds, if I had not had any prior parachute knowledge, or if I had a less capable seat, I would not have cleared the fireball. 4 thoughts on my ejection. Firstly, when the aircraft pitched out of control, I did not even consider the option of ejecting, even though I knew I was at very low altitude. Secondly, I did not realize that the aircraft was not going to make it until the nose pitched down, back up again, and I looked out at the ground. Once I had made up my mind the aircraft was not going to make it and I had written off the aircraft, only then did I turn to the question of survival. And finally, things happen a lot quicker than you think you're going to. You don't have as much time as you think.
During a strike exercise involving multiple aircraft, an F-15A was involved in a mid-air collision.
I'm Captain Bob Devos. I'm an F-15 pilot stationed at Holloman Air Force Base in New Mexico. On October the 3rd, 1979, I was commander of a composite force training mission past a close escort F-4 fighter bomber into and out of the Fowler Naval Air Station Range complex in Nevada. As I unloaded and rolled away from my last kill, I instinctively rolled to my right, and what I saw ruined my whole day. Another F-15 on an imminent collision course. The mid-air collision severed the nose of my F-15, disintegrated the canopy and windscreen, and instantly blinded me. I immediately reached for the ejection handles and ejected myself in the Aegis 2C at approximately 350 knots indicated airspeed and 20,000 feet MSL. The ejection sequence was both violent and instantaneous, very comparable to being fired out of the end of a shotgun. The most important thing about the ejection sequence was that I was alive. And the reason that I was alive was because I made the decision to eject, and then I executed that decision without any hesitation. I might add that I did not make the decision to eject on October the 3rd, 1979. This was a well-thought-out process over many years of flying. That is, my philosophy had always been, if I got myself into a situation where I could not determine the attitude or the capability of my aircraft, then I would eject, regardless of who was to blame. My message is simple and straightforward. If there is any doubt about the status of your aircraft, leave it. We can always rebuild the aircraft, but we cannot rebuild the pilots.
There you have several ejection experiences from fellow crew members who, like you, fly some of the present Air Force inventory.
Speed in today's aircraft has doubled and quadrupled from that possible in older models only a few years ago. These higher speeds mean a reduction in the time a pilot has to perceive, to interpret, and to appropriately react. We no longer have the luxury of time to deliberate for a decision. you, today's air crews, must be able to meet the challenges presented by the aircraft that you fly. The time to think about what you will do if an out-of-control situation occurs is on the ground. Up there, the solution must be automatic. If ejection is warranted, then it too must be without hesitation. We all knew guys who didn't.
All too often the accident report reads, pilots selected the wrong course of action by attempting to recover the aircraft from an out-of-control situation, one that was impossible to recover. Wasting those few precious seconds can not only be critical, in the ejection world, it can be fatal. Don't let it be said that you ejected a second too late.
With demands placed upon it by improved aircraft performance, more complex missions, and more low-level flying now required in the current training environment. There must be time for the ejection sequence to fully operate prior to ground impact.
Therefore, delaying the decision to leave the out-of-control aircraft is and has been the single most critical factor in determining the success or failure of in-flight escape.
This is borne out by the high fatality rate in escape attempts outside the performance envelope of the system, at low altitudes, particularly below 500 feet.
No matter how good the escape system, you've got to give it time to work. As flight surgeon at the safety center, I reviewed many accident reports involving the delayed ejection, and they always illustrate at least 2 points. One, these seats...
of an F-4 crew. Moments before they were faced with the most critical decision, when to eject from their out-of-control aircraft. A delay in making this decision, for whatever reason, may well have cost them the opportunity to make a successful escape, and added 2 more statistics to the ever-growing number of Air Force aircraft fatalities. Fatalities that shouldn't, but continue to happen.
Since the first aircraft ejection in August 1949, there have been 4,600 air crewmen who have punched out. Of these, if we concentrate on the ejection survival rate for the last 5 years, we see a less optimistic picture. Here, the survival rate average drops to 75%. Accident analysis reveals that the majority of these fatalities were not due to mechanical problems, failure of the egress system, or improper parachute landing technique. Rather, they were the direct result of delayed ejection. The Air Force Inspection and Safety Center is well aware of this problem.
Single motion initiation, rocket catapults, automatic opening lap belts, ballistic powered inertia reels, seat man separators, seat stabilization devices, force deployed parachutes, and automatically deployed survival kits are just some of the improvements which were designed to facilitate crew members' escape. Some of our newer aircraft, such as the A-10, the F-15, and the F-16, are equipped with the new ACES 2 ejection seats that even surpass our other highly refined escape systems. There is some evidence that tends to suggest that many air crew members interpret escape system improvements as being additional time to overcome an emergency. This, of course, is not why escape systems are improved. They are improved to give crew members a better chance to escape.
Yet, in spite of the many safety improvements, escape technology is still having a hard time keeping...
We should have good brain masking back here. Yeah, we're safe now, except for the mirror.